Ever stop to think about how it all works? Sending an email, streaming a movie, even just loading a web page. Well, today we're pulling back the curtain on the OSI model, the hidden 7-layer blueprint that honestly makes our entire digital world possible.
I mean, really think about it. You've got your phone, your laptop, some server halfway across the world, maybe even a smart fridge. They're all completely different. So how do they all communicate so perfectly? There has to be a shared set of rules, right? A common language they all understand?
And that's exactly where the OSI model comes in. It is the universal translator for all things tech. It's this 7-layer blueprint that standardizes the whole process, laying out precisely how a piece of data gets from your screen to a server across the globe and all the way back again.
Okay, let's dive right in, and we're going to start from the ground up. Before we can even think about crossing the globe, we have to understand how devices talk to each other when they're right next door, on the same local network, like in your house or your office.
This whole local conversation is handled by the first two layers of our model, the physical layer and the data link layer. These two are the absolute bedrock. Nothing else happens without them.
So, layer 1, the physical layer, is all about the tangible stuff, the hardware you can actually touch. We're talking about raw bits, the ones and zeros, being turned into physical signals. Think of the electrical pulses zipping through an Ethernet cable, flashes of light in a fiber optic line, or the radio waves for your Wi-Fi. It's simple. If your cable's unplugged, nothing else matters. This is where it all begins. Now, building on top of that, we have layer 2, the data link layer. This layer takes all those raw bits and organizes them into neat, structured packages called frames. And here's the crucial part. It attaches something called a MAC address to that frame. You can think of a MAC address as a permanent, unique serial number for your device's network card. It's like a fingerprint. This is what makes sure that frame gets delivered to the correct computer on your local network.
So, we've got our local connection sorted. But how do we get data from your network out into the massive, sprawling internet? Well, this is where the real magic begins to happen.
This incredible global journey is orchestrated by the next two layers up, the network layer and the transport layer. You could say that together these two really are the heart of the internet.
Layer 3, the network layer, is basically the internet's GPS. While that MAC address finds a device on your street, an IP address is like the full global mailing address for your device. This layer uses that IP address to figure out the most efficient path for your data to take across the entire internet. And the key hardware here? Routers. They're the traffic cops of the internet, directing all that data from one network to the next.
This brings us to layer 4, the transport layer, which is all about the quality of that connection. And you have two main choices here. On one side, you've got TCP. It's the reliable one. It sets up a connection, checks for errors, and makes absolutely sure every piece of data arrives in the right order. Think of it like sending a certified letter. This is what you need for a web page or an email. But on the other side, you've got UDP. And UDP is all about speed. It just blasts the data out there without all the checking. It's perfect for things like video calls or online gaming, where a single lost packet is way less noticeable than a stuttering, laggy connection. All right, we've done it. We've moved our data across the world. But now, how do we make sure the software on the other end can actually understand and use it? That's the job of our top 3 layers.
These final layers, session, presentation, and application, they act as the ultimate bridge. They connect all those complex network operations we just talked about with the software applications that you and I interact with every single day.
Think of the session layer, layer 5, as the conversation manager. Its job is pretty simple but super important. It opens a stable communication channel between two devices, it keeps that conversation going smoothly for as long as it needs to, and then it closes it down properly when you're done. This is what keeps a long video call or a remote desktop session from just dropping out.
Next up is the presentation layer, which is our universal translator. It takes all that data coming from the network and makes sure it's in a format that the application can actually understand. This is where really important stuff happens, like encryption to keep your data safe and sound, and compression to make files smaller and faster to send. It's what turns raw data into a recognizable JPEG image or an MP4 video file.
And finally, we've reached the top, layer 7, the application layer. Now, here's a super important distinction. This is not the application itself. It's not Chrome or your email client. Instead, it's the protocol that the application uses to talk to the network. HTTP is the protocol for the web. SMTP is the protocol for email. It's the language that our apps use behind the scenes to get things done.
So, now that we've met all 7 layers, let's put it all together. Let's trace a data packet's full journey for something as simple as loading a web page. What does that actually look like?
It all starts on your computer, of course. The moment you type in a web address and hit enter, you kick off this incredible chain reaction. Your request begins its journey by traveling down through all 7 layers of the OSI model, one by one.
Okay, let's follow the data down the stack. At layer 7, your browser creates an HTTP request. At layer 6, that data gets formatted and encrypted. Layer 5 opens up the communication session. Then, at layer 4, the data is chopped into segments using TCP for reliability. Layer 3 slaps the server's IP address on it. Layer 2 packages all of that into a frame with the MAC address of your local router. And finally, layer 1 converts the whole thing into electrical signals and sends it on its way.
Once those signals finally reach the web server on the other side of the world, the entire process just happens in reverse. The server rebuilds your request by moving back up the stack. From layer 1 all the way to layer 7, it figures out what you want and then sends the web page data all the way back to you, following that same 7-layer journey home.
And that's the real beauty of it. This incredibly structured, layered system is what lets the internet function so consistently. It's why a brand new iPhone can talk to a 10-year-old server without a single problem. It just works.
So, beyond being a pretty fascinating piece of computer science, why does any of this actually matter in the real world? Why should you care?
Well, for anyone in technology, this model is absolutely essential. If your internet is down, what's the first thing you do? You check if your Wi-Fi is on or if the cable's plugged in. That's a layer 1 problem. Can you get to some websites but not others? That could be a layer 3 routing issue. The OSI model gives you a logical checklist for troubleshooting. It's also the foundation for designing new networks and for understanding cybersecurity, because attacks can target any one of these 7 layers.
And that really brings us to a final thought. Even today, as we move deeper into a world of cloud computing, wireless everything, and the Internet of Things, this framework, a model developed over 40 years ago, still perfectly describes the fundamental principles of how information moves. It's an amazing testament to its design, and it continues to define our digital reality every single day.